Welcome, fellow knowledge seekers, back to the book recap. Today, we're venturing into the mind bending world of cosmology and physics with one of the most influential science books of all time, A Brief History of Time by the brilliant Stephen Hawking. Prepare to have your mind blown as we explore the universe from its birth to its ultimate fate. This book isn't just about complicated equations and scientific jargon. Hawking takes us on an incredible journey explaining complex concepts with clarity and wit, making the wonders of the cosmos accessible to everyone. So buckle up, get ready to expand your understanding of the universe, and let's dive in. From ancient myths to the Big Bang, our journey starts way back with the ancient Greeks. They imagined a geocentric universe with Earth at the center surrounded by celestial spheres, holding the sun, moon, stars, and planets. This model, championed by Aristotle and Ptolemy, lasted for centuries. Then, in the 16th century, Copernicus threw a wrench in the works by proposing a heliocentric model placing the sun at the center. It took decades of debate and observation with pioneers like Kepler and Galileo for this radical idea to take hold. Enter Newton, laws of motion and gravity, but the real revolution came in the 17th century with Isaac Newton and his groundbreaking work Principia Mathematica. Newton introduced his three laws of motion explaining how objects move and interact: inertia, acceleration, and action-reaction. He also gave us the law of universal gravitation, that every object in the universe attracts every other object with a force depending on their mass and distance. This explained not only why things fall to the ground, but also the elliptical orbits of planets around the sun. Newton's work shattered the idea of a finite universe, suggesting an infinite expanse of stars instead. Einstein's universe. Relativity rocks our world. Fast forward to the 20th century, where Albert Einstein enters the scene with his mind-bending theories of relativity. First, special relativity, which states that the laws of physics are the same for all observers, no matter how they're moving. This introduced the mind-boggling concepts of time dilation. Time is relative and slows down at high speeds, and the equivalence of mass and energy. Then general relativity, which brought gravity into the picture. Einstein proposed that gravity is not a force, but a consequence of the curvature of spacetime caused by mass and energy. Picture a bowling ball and a trampoline, it warps the fabric, right? That's what massive objects do to spacetime. This theory predicted the bending of light around massive objects and the slowing down of time near strong gravitational fields. Pretty wild stuff. The expanding universe, Hubble's big discovery, and the revolutions kept coming. Astronomer Edwin Hubble observed that distant galaxies are moving away from us, indicating that the universe is expanding. This, coupled with Einstein's equations, gave birth to the Big Bang theory, the idea that the universe began in an incredibly hot, dense state, expanding and cooling ever since. Hawking even talks about evidence for the Big Bang, the cosmic microwave background radiation. It's a faint afterglow of the universe's intense heat detected in all directions. Into the quantum realm, uncertainty and weirdness. Now get ready for things to get even weirder as we delve into the microscopic world of quantum mechanics. First, Heisenberg's uncertainty principle. You can't know both the position and velocity of a particle with perfect accuracy. This introduces an element of randomness into the universe. Then wave-particle duality, the idea that particles can act like waves and waves can act like particles. This led to the mind-bending concept of quantum entanglement, where particles are linked in spooky ways. Unifying the Forces, the search for a theory of everything. Hawking then explores the quest to unify the four fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. He describes successful unifications like the electroweak theory and ongoing efforts with grand unified theories. The ultimate goal, he says, is a quantum theory of gravity, a theory that unites all four forces and reconciles general relativity with quantum mechanics. Black holes, not as black as they seem. Now let's journey to the edge of space-time and explore black holes, regions where gravity is so strong that nothing, not even light, can escape. These cosmic monsters form when massive stars collapse. They have an event horizon a point of no return and a singularity at their center where the laws of physics break down. But here's the twist. Hawking radiation, Hawking's own groundbreaking discovery, shows that black holes aren't entirely black. They emit radiation due to quantum effects eventually evaporating completely. The big questions, the beginning, the end, and the multiverse. Hawking also tackles profound questions about the universe's beginning and end. He proposes the no boundary proposal. The universe is finite but has no boundary or edge existing in a state of imaginary time. Then there's inflationary theory, which posits a period of superfast expansion in the universe's earliest moments, smoothing out irregularities and leading to the universe's large-scale uniform. And perhaps most mind-blowing of all, the possibility of a multiverse, the idea that our universe is just one of many. The arrow of time, why we remember the past. Hawking then explores the fundamental question of why time seems to move in one direction. He talks about three arrows of time: thermodynamic, psychological, and cosmological, and explains how they're all connected. Wrapping up, the universe in our minds. A brief history of time leaves us with a sense of wonder and awe at the vastness and complexity of the universe. It also reminds us that science is a journey of discovery, and our quest to understand the cosmos is a testament to the power of human curiosity and imagination. So if you're ready to explore the universe from the comfort of your own home, grab a copy of A Brief History of Time and prepare to have your mind blown. Don't forget to subscribe to the book recap for more mind-expanding book summaries. And until next time, keep exploring the cosmos